Hi. Welcome. Thanks for coming to this talk. I'm going to argue in this talk that technical debt isn't technical, which sounds like a bit of an uphill struggle, but we'll see how it goes. My name is Einar Høst. I am a Norwegian software developer. I've been programming for money for a little over 20 years now. I am working as a socio-technical advisor at the Norwegian Labor and Welfare Administration. And what I do in that role is that I try to help teams with the things that tend to make software become more difficult to do over time. And one of those things is technical debt. A technical debt is one of those terms that I'm sure all of you in this room are familiar with. But I'd like to, basically what I'm going to do in this talk is I'm going to try to ask a bunch of questions and then maybe draw out some answers and then ask more questions to those answers, and we'll see, we'll go on for 50 minutes doing that, basically. Okay, so what is this technical debt thing? Well, I'd like to start this sort of investigation by considering technical debt as a meme. And when I say meme, I mean not in the sort of funny pictures on the internet kind, but more like the idea of memetics that was set out by Richard Dawkins in the book The Selfish Gene, where he suggested that, similar to the way that genes work, there is a concept that ideas work in the same way, that they compete, right? So memes, or ideas, are these self-replicating units of thought, and much like genes are sort of building blocks for organisms, these memes then are exposed to similar forces, and they also mutate and compete. And these memes then are sort of copied from brain to brain. And that's sort of the goal of the meme, is to accomplish this copying task. Richard Brody wrote a book called Virus of the Mind, which is a really interesting title, I think. It implicates that the memes need a host, but they're not really caring about the welfare of that host too much. The goal for the meme is just to survive and to spread. Now, an interesting question then becomes, well, what makes a meme compete successfully, right, against other memes? What does it mean, survival of the fittest in the world of ideas? Is it sort of the ideas with the greatest explanation power? Because that's sort of what we want, right? That the best ideas sort of rise to the top and the bad ideas sort of simmer at the bottom. Or a very different perspective would be something that makes us as hosts feel good about ourselves. Right? Something that reduce the tendency to build up cognitive dissonance, because cognitive dissonance is kind of uncomfortable, so we'd like to avoid that. So there's this tension here between the best ideas and the ideas that make us feel good. And I just want to sort of have that as a backdrop, something simmering in the back of our minds as we're doing this investigation into technical debt. Now, technical debt is a metaphor that was coined by Ward Cunningham a long time ago now. I think it's approximately 30 years old, this metaphor of technical debt. And what Ward Cunningham originally said was this. And I'd like to, this is a lot of text, but I'd like to read it out loud, because this is sort of the context for the metaphor. And often we lose a lot of context over time, so we should try to regain some of that lost context. So what it said was that shipping first-time code is like going into debt. A little debt speeds development as long as it's paid back promptly with a rewrite. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt, and entire engineering organizations can be brought to a standstill under the debt load of an unconsolidated implementation. Now, what strikes me with this quote it's kind of a rich metaphor, right? And I think that over time we've lost a lot of that and basically just distilled into these two words, and then we're sort of free to associate whatever we might from that. But okay, let's talk about it some more. What are some things that make technical debt into a good metaphor, something that's useful for the host, if you like, if you're thinking about the competition of memes? Well, the reason Ward Cunningham invented this metaphor was that he needed to talk to people who couldn't look at the actual code about something that was important, right? And without some means of talking about those things, you have nothing to say. And so this metaphor helps put this idea that there's something else besides the functionality of the software that sort of matters, which is the structure and the integrity and the quality of the software as well. And it sort of helps put that on the agenda. And it helps, to some extent at least, to make sort of this invisible thing more visible, at least makes it talkable. It's still not really visible, right? But we can talk about it. And it has been successful in that regard, that people do believe that there is such a thing as technical debt. It's a real thing, in a sense. So for that, I think we should be very grateful to Ward Cunningham. Now, let's talk about some potential shortcomings. What are some difficult or problematic things with the technical debt metaphor? Well, first of all, sort of your regular monetary debt is very easily quantifiable. I know exactly how much sort of debt I have on my house, right? And if I forget, I just log into my bank and there it is. It's a number. I can look at it. And I know how much interest I pay each year as well. And I have a plan. In fact, the bank set up a plan for me on how I should repay my loan, right? So it's very easy to understand. Technical debt is much harder to measure. There are tools out there that will sort of claim to measure technical debt. They measure something. I think it's something related to code complexity, probably. But degree to that is actually your technical debt, well, that's up for discussion, I think. But it's very important, right? But it's important to know how much technical debt do we have and how big of an interest are we paying on that debt. And there are even sort of more fundamental questions, like, are we technically solvent? And what does that mean? Is it possible to go technically bankrupt? And I think the answer is kind of yes, because this is what Ward Cunningham was hinting at when he said that entire organizations can sort of grind to a halt. You're no longer able to produce more value. Okay, let's dig even further. What is this technical debt thing? We have to distinguish a little bit, I think, between how it started and how it's going. Now, the process that Ward Cunningham was describing is a very deliberate process. You make the choice to go into production early with sort of known debt, known shortcomings in the code, maybe some even known bugs. There are things perhaps you don't fully understand or you don't know the right way to do something, but you go into production anyway because you want feedback. You want to learn something, right? And then when you get feedback, you feed that back into your code. That's sort of the process that he was talking about. And I think with respect to how it's going, technical debt is used much more broadly than that. Basically means any code that doesn't feel right or have some shortcomings in some way. And a lot of that is incurred inadvertently. It just sort of happens. We don't set out to do it deliberately, but over time, well, it turns out we have accumulated a bunch of this debt. Right. So this broad understanding, this later understanding I was talking about, what does it look like? And what do we mean when we say technical? When we say technical, I guess we mean exactly the same thing as when we distinguish between sort of technical and non-technical people. It's just sort of a code word for it has to do with the code, right? So it's in a sense code debt, right? And what is it? Is it just an ugly code? Is that it? Is it basically just another word for ugly code? And what causes it? If it is ugly code, what makes the code ugly? No one sets out to write ugly code, I think. So why does it turn out ugly? A lot of developers tend to blame lack of time. So there's this external constraint out there that doesn't sort of yield the necessary conditions to produce pretty code, and so we get ugly code instead. Or sometimes we say that our project manager or maybe our product owner doesn't understand me, and if they did, we wouldn't be accumulating this debt. Or maybe the user experience people have unrealistic demands, and there's no possible way we can do it in a meaningful way, and we just do it as best we can. Or maybe the previous developer was incompetent. That happens all the time. We are never the previous developer. So what does it look like? Like concretely? From my experience, I don't know about, whoa, what just happened? Whoa. Okay, from my experience, having worked as a developer for 20 years, it looks like this. It's a pile of Boolean flags and if branches and indirections. It's a little bit like this, right? It's a sort of programmable roller coaster. Each person gets their own ride, and you push different buttons and pull levers. And if someone gets the wrong ride, you sort of make an exception for them. Basically, just add another Boolean and a branch, and then they get the right ride, and you sort of patch on from there. In code like that, it tends to be very hard to sort of isolate code related to a single feature. It's sort of jumbled together, tangled with everything else. It's difficult to determine where one thing ends and something else begins. And for those reasons, it's very difficult to predict the effect of change. If I change something over here, is it going to affect something over there or over there or over there? And in general, it's difficult to reason about the code, and we need to reason about the code if we are to extend it or change it in some way. And that's basically what we do. Now, so what does this indicate? And does it match our explanations that we set out earlier? Well, I don't know. Not really, maybe, a little bit. It seems to me that there's something even more fundamental that is going wrong. And I think there's something that's gone wrong, basically, well, this is quite obviously, I just described it in a sense, that we haven't been able to establish clear boundaries in the code. We have failed, in a sense, to capture the business domain in software. And we have failed in the process of letting the code co-evolve with the business, in a sense. Because that's what we try to do when we sort of make software over time. Right? And we have a word for this process. It's called modeling. So modeling has failed. And what is modeling? Well, modeling is, in a sense, two things at the same time. It's applying abstraction to a problem domain, and it's also simultaneously defining what that problem domain is. So it sort of happens at two levels at the same time, I guess. Whenever you bring up modeling, people get a little bit skeptical. And they say, well, are you suggesting that we should model everything, a big design up front, and then we just implement? We know from 20 years ago that this process doesn't work. But no, there's nothing in the concept of modeling that says that it has to happen once before you start coding. It's a continuous process. Right? You do modeling continuously as the software evolves. And in fact, Ward Cunningham said as much. He said, you're wise to make the software reflect your understanding as best you can. Right? This is modeling. You need a good domain model that you can represent in the software itself to represent your understanding in the code. But okay, so let's say that our modeling efforts have been inadequate for whatever reason, and we have accumulated some of this technical debt. How do we pay it off? Now, if you're software developers or you work in software, you know the answer to this one. Like, it's refactoring. We sort of refactor it away. Now, which refactoring is it again that, remind me, which refactoring fixes a tangled mess of weak abstractions? And this is, I took a screenshot from refactoring.com. These are the refactorings available to us. There are these tiny little atomic operations that sort of conserve the behavior of application, right? They are safe to do. So there are things like pull up method, remove name parameter, remove parameter, add parameter, stuff like that. Very tiny operations. There's nothing in the concept of refactoring itself that gives you a strategy of how you should sort of compose a bunch of these into doing something meaningful. In fact, Sarah May notes that sort of rewriting something is meaningless unless you close the understanding gap. Right? You need better insight into the problem that you're solving, otherwise it's just going to waste effort, right? Because you're going to reproduce exactly the same problems. So there's very little point in undergoing sort of like large refactorings, like your refactoring sprints or whatever, unless it's driven by also a remodeling effort. Right. Basically, you should obviously sort of do continuous refactoring as you're evolving things, but sort of these larger things, you need to have it driven by a remodeling effort. Anything else, I'm sorry to say, is basically just developers being a little bit naive, I think. But it's very tempting, right? We'd like to be this come as savior with our sort of awe-inspiring programming chops, right? Our best practices, and we can fix everything because we're not as incompetent as the previous developer. But in practice, it often ends up like this. It starts out really well, right? But at some point, we hit a wall, and it's not that easy anyway. And the problem and the reason is that these so-called best practices are not enough. Now, don't get me wrong, best practices are fine, and we should use them, right? This is the best we got. It's just insufficient. And I like to compare it a little bit. Imagine you're a surgeon, and you're supposed to operate on some person. Now, hygiene is very important, right? You wash your hands, or whatever you do to disinfect your hands these days. But that alone is not going to save the patient, right? You also need to carry out the actual procedure, right? So best practices is sort of hygiene. So clean code, or whatever you want to call it, is not going to save you if you have a rotten model. So you sort of need to start, and if you do, you will waste time and money. So you need to start by fixing the model, like your conceptual model of the problem that you're solving, and then you can sort of hope to fix the code. Okay, so are we done now? Is the talk over? Can we go home? Or maybe go have a cup of coffee and wait for the next talk, I guess. Well, how do we fix the model? I have a bunch of questions. What causes this modeling debt? So here we go again, I guess. Right? But just in case you're not entirely convinced about the importance of modeling and how it contributes to the notion of technical debt, I'd like to tell you a little bit of story. This is a story I invented myself. It's a completely artificial story. But it's not too unlike experiences I've had in my career. This is a company called Equest. It deals with entities of this kind. It's a software suite for horse owners, and it sort of supports everything you do with horses, which I guess is stuff like, well, probably you have to feed them, breed them, you do racing, you do parades. That's what I imagine horses do. And Equest is quite successful in the market. In fact, it's so successful that your product owner wants to branch out and try to capture new market share, right? So you want to handle this new additional kind of horse. Now, this is a very interesting kind of horse, right? Compared to other horses, they are said to be short and strong and quite stubborn. Some people say they're just not really stubborn, they're just quite intelligent, and so they don't want to do things that seem harmful or meaningless to them, right? They have this strong sense of self. And everyone agrees that this should be easy to support, right? It's just another kind of horse. So there should be a lot of code reuse, right? Now, this is fine, but discussions in the team are suddenly a bit more difficult, because what do we mean when we say horse now? Do we mean this one, the old one, or both, right? The old and the new. And then sometimes we mean the former, sometimes we mean the latter, and it's a little bit confusing. And for that reason, we invent these qualifiers, adjectives, to attach to the nouns. Right? So this is now a regular horse, or a typical horse, or a true horse, an old-fashioned horse, or my favorite, the horse. And with this in place, now we sort of solve the problem with ambiguity. In the code, we can sort of check and branch like this for cases where you can't really treat them the same, right? So you branch out. So you check if it's short and stubborn, and you can sort of distinguish between the, and make sure that you get the right business logic for each case. And this goes fairly well, but unfortunately, in production, there are bugs, and how can this be? Well, it turns out that some horse owners have these sort of regular old-fashioned horses that are kind of short and kind of stubborn, and so they get mislabeled, and they get the wrong logic, and everything is kind of bad. But nothing we can't fix, right? The developers at Equest are pragmatic people, and they talk to the domain experts. So it turns out this new kind of horse also makes this distinctive sound. It says "ee-haw," whereas the other horses, they don't. They do something else. They neigh. And this seems to fix the bugs, The code is a little bit less pretty now, but that's okay, I guess, it works. And in fact, it works so well that the product owner thinks it's time to branch out even more to handle this new kind of horse. What is it? That's a good question. It is the kind of horse that is the offspring of a regular horse and a short and stubborn horse that goes yee-haw, because they can breed. And the product owner is really enthusiastic about this one, because now you have sort of the old horse and the new horse and something in the middle. Surely you can reuse all the code you have from before, right? It must be trivial to handle, should be done very quickly. This one is hard to talk about in meetings. So maybe desperately you try to invent some new word. You say, can we call it a half hee-haw or something? But no one does that. Everyone calls it a horse, and there's confusion, but you sort of apply this, you basically just read out whatever description you have to sort of disambiguate if you have to. But even though it's hard to talk about, clever developers can always write the code. Right? You just need to be a little bit careful to get sort of the right mix of things in each case. It's unfortunate and almost a little bit unfair, though, when you go through all that hard work, there are still bugs. And how can it be? What went wrong? Well, here's the thing. Is it the mother or the father that is stubborn and strong and goes yee-haw? And as a developer, you'll be excused if you ask, what does it matter? And it matters because it turns out that only one of these can have offspring. So you get bugs in the breeding module because of this. At this point, as a developer, you start using the phrase technical debt, because things are not proceeding as quickly as the product owner expected. But of course, business goes on, and now we have this, and everything is kind of bad. So hopefully, this is an argument that modeling is kind of hard. And I think modeling is hard for three main reasons. The first thing is the stuff that we try to model, which is reality, in some sense. The real world hits us. Then there's change, or time, and the change that time brings. And finally, it's us. We're always part of the problem, I guess. Let's start with the first one. The basic problem is that reality has no interest in being modeled. It doesn't care. Right? It's completely unaware that we're doing the modeling, and it feels completely free to change if it feels like that. It's not tidy and organized. It's not even consistent. Right? It's this messy and organic thing that slips away every time we sort of think we have grabbed it in some sense, evolves away from us. And the problem is that when we're modeling, we're trying to impose some of our structure, right? Structure that we invented, onto something that's unstructured. And it's even worse than that in a sense, because we're trying to impose something that is static onto something that's dynamic. Right? And that implies that we need to keep doing it. We cannot do it up front, so it needs to be a continuous process. And in a sense, it's not breaking models is not even necessarily a bad thing, right? Because innovation requires you to break models. You cannot have innovation unless you break someone's mental model of something. Right? You need to change it. I recommend reading a book by William Kent called Data and Reality. It's an old book, and all the good books are old, right? It talks about some of the fundamental building blocks we use in our efforts to try to structure the world. This includes things like identity. What does it mean for something to be one thing? And also the related concept of equality. When are two things equal, and when are they the same thing? Is it the same to be equal and to be the same? Now we're getting a little bit philosophical, but it's interesting to consider. It talks about change. When do two things that used to be equal become distinct? Can they change to become, they used to be the same, but now they're not, right? And when can one thing change into something else? And this also talks about categories, which is kind of related, and also related to what we were talking about with the horses. What category does a thing belong to? Is it possible for a thing to change category? And if it changes category, is it still the same thing? And on the topic of categories, I also recommend this book, Women, Fire, and Dangerous Things by George Lakoff. Excellent book. Now, the classical theory of categorization, the way that we're used to think about categorization is based on properties. This is the way that we've done it for the last 2,000 years, up until around 1970. And it should be very familiar to software developers because categories resemble then classes in programming languages like Simula and Java. Simula, of course, being sort of the original gangster object-oriented language invented in my home country of Norway in the 60s. So the idea is that you have necessary and sufficient properties to determine category membership. And that sounds reasonably enough. But if you'll indulge me, if you can close your eyes and try to envision a bird, just try to think about a bird. Are you thinking about a bird? I'm thinking about a bird right now. Does it look like this? This is a bird. This particular kind of bird is a penguin. If you're like most people, it probably looked more like this. And this is a sparrow. Is this also a bird? I was thinking about this one. My favorite bird is the shoebill. I'm going to guess that I was the only one who was thinking about the shoebill. But who knows? The idea here is that some members of a category are more typical than others, and so they spring easier to mind. And if you like, a sparrow is more birdy than a penguin is. Right? It's more birdy than a shoebill. And in fact, I think the sparrow is probably the birdiest bird there is. Now, this notion that there are sort of degrees of membership was pioneered by Einar Høst in the 70s. It's called prototype theory. And the sparrow is sort of the prototypical bird. And then the idea is that the shoebill and the penguin, while still birds, they are sort of further away from the prototype. And at some point, if you sort of venture too far off, the thing has become too untypical to be considered a bird, or a member of the category in the general case. And so it's interesting to consider these questions: how untypical is too untypical, how unequal is too unequal? And if you like, when does a donkey become a donkey and not just an unusual horse? And the answer is, it depends. There are no correct answers to this question. It depends on our context, right? Who's asking? Who's answering? And certainly the donkey doesn't care, right? To paraphrase Shakespeare, a donkey by any other name would smell exactly the same. So it's us, we put things into categories to try to make sense of reality. Now what's difficult about this is that these generalizations that we make are hypotheses about the future. Right? We make decisions, we put things into categories today, and we hope they stay there. We hope that the world doesn't change in such a way that they no longer fit in our boxes. But this might break. And for that reason, we should be very careful about introducing sort of artificial ad hoc generalizations, because it might turn out they were wrong or not useful to us. And the reason is because the world changes. Now, when we implement features in software, it requires us to make some decisions, and these decisions necessarily rely on some assumptions. Basically, an assumption about the world as it is today and how we think it's going to look tomorrow and next year and the year after that. The problem is that these assumptions accumulate over time, and assumptions necessarily limit our freedom, because we made one assumption today, another one the next day, and so on and so forth. And at some point, we can no longer choose freely, because we have to consider all the assumptions we made before. I think it's useful to think about sort of the accumulated load of all these assumptions and the relationship it has to the notion of technical debt. And this is from a Norwegian TV show called Mesternes Mester. These are retired athletes competing in various events. This is the event known as Gravity. And what this poor guy is doing is he's walking these rounds, and for every round, you can call it like a sprint, right? He's walking these sprints, and he's picking up a bag of sand for each sprint. And eventually it gets pretty hard to move. This guy did really well. The problem is, of course, then change hits us, because it's not just the accumulation. Sometimes you need to sort of change the bags itself, right? Because it's not just adding new features, we're also changing existing features. And developers are often asked things like, well, how long does it take to implement this feature? And the correct answer to that is basically, how does this feature change our domain model? Right? If you're going to answer that, you need to consider questions like this. are there any assumptions that we've made that are now invalidated by this new feature? How many decisions have we made that must be now undone and remade because we need to support this new case? And how much structure have we built that relies on these obsolete assumptions and decisions? Now, obviously, this includes technical structure, which is like code. Our assumptions and our decisions are woven into the code and the architecture itself. But there's also sort of other kinds of structure, like organization structure. You know, Conway's law, it talks about how technical structure and organization structure tends to mimic each other. And when we're talking about economics, organization structure, you also have to talk about economic structure, because if you want to move people, you typically have to move money as well, right? And since money is power, in a sense, moving money means changing power structure. This is harder to do than moving code. Now, the problem is, these are not even independent. They are sort of these intertwined and mutually reinforcing structures. Now, when we try to respond to change, we do so under a constraint of time and money. We cannot spend infinite time trying to respond to any given change. And for that reason, when we respond to change, it tends to be imperfect, tends to leave some sort of residue, because we have to move on, right? So in trying to explain the problem of sort of accumulating assumptions and how it relates to things sort of slowing down when we do software development, I sometimes like to compare it to the game of Tetris. Now, Tetris is a very interesting game because you cannot win at Tetris, you can only lose. And the goal is to try to play as long as you can. And so you have perhaps something, you made an assumption, right? It left a residue. You had some indecision, that left a residue. You made a generalization that didn't hold, that left a residue. There's some ambiguity somewhere, that left a residue. You had some misunderstanding, plain old misunderstanding, that left a residue. There was some conflict among different stakeholders of what a feature should be, that left a residue, and then it's game over. So the question then is not really how do we win, but how do we play well? How do we slow down this process? Because that's what you can do in Tetris, right? You can fit the pieces together so that the rows go away, and then you can keep playing. And if you want to do that, you need to include people, us. Modeling is hard, not just in and of itself, but also because people don't like doing it. And there are some good reasons for that, really. In a sense, I think of modeling as metaprogramming the mind, because we sort of have, when we're doing modeling, we have to try to change the building blocks that we use to think about the problem while thinking about the problem at the same time. And that can be uncomfortable. Right? If you're not used to that, it can be quite uncomfortable. And so when you try to bring up modeling issues, you might be met with questions like, why are you making things so difficult? Of course, you're not making things difficult. You're trying to sort of expose the difficulty that's really there. And the real answer is to avoid making it unnecessarily difficult over time. But still, you can be met with questions like this. And this is very unfortunate because communication is already scary. And communication about hard things that people don't want to hear or don't want to discuss is even scarier. Right? I think we should talk a little bit about the general reluctance to talk. Now, unless it's perfectly clear, this is me sitting at my desk. As you can tell, I've been a backend developer for my career. I need to keep it simple. So I have a Jira ticket. I need to implement some feature. But for whatever reason, there is some ambiguity. There's something unclear about the task that I'm supposed to do. And maybe there are several possible interpretations or different solutions with different trade-offs and so on and so forth. When this happens, I'm going to be under the strongest force that a software developer knows, which is the desk force. This is a force that tries to keep me sitting at my desk, not leave it. This is kind of a joke, but it sort of really isn't, because if I leave my desk, I'm entering the land of unknown trust. Because I know that I have to talk to someone. Maybe I know who I should talk to, or maybe I know someone who could tell me who I should really talk to. Chances are I'll have to cross the chasm from sort of my coworkers, my fellow software developers, and into the land of the business domain, right? This is potentially quite scary. And also, if I do decide to do that, the information content in our exchange, in our conversations, is going to be determined by our mutual trust. And of course, the people I approach might also be reluctant to talk. They might be uncomfortable with that. And if I do decide to leave my desk and talk to someone, I'm going to have to articulate the problem. And maybe I don't know exactly what the problem is, I just know it's a problem. And I have to articulate it in such a way that someone can understand me, right? And if they don't, I'm going to feel stupid for asking the question in the first place. I'm going to have to justify my opinions if I have any. I might have to enter discussions and negotiations because there is an ambiguity to resolve. Right? We need to do something about it. There's even the possibility of conflict. Maybe I'm unwittingly marching straight into a really contentious issue, a minefield of organizational politics, really. Right? Because why is there an ambiguity? Now, it could be, of course, that whoever wrote the task is just bad at expressing themselves. They left out some necessary context for me to understand it properly. This is probably the most common case, but it could also be sort of like indecision and conflict hidden there. Right? Maybe there are different stakeholders having different ideas of the direction the product should be going in, and natural language is excellent at sort of glossing over those differences. Just leave it sufficiently vague, and we're good. Do I want to trigger that? Of course I don't. So my self-defense mechanisms kick in, and I start making up arguments for why I shouldn't be talking to these people, why I should be sitting safely at my desk. I say things like they're probably very busy, I can't bother them with this. No one else seems to be asking these kinds of questions, and what about the estimates? Right? This is already estimated to take 2 days. If I start this investigation, it's going to take at least a day just to get the meeting, and then there's going to be discussions, and so on. It could take weeks, right? Won't someone please think of the estimates? So my brilliant mind comes up with this idea. I can solve it by making an assumption. I'm just going to guess that it's this thing, right? I'm calling it an assumption because it sounds nice, and it sounds like something that's reasonable to do. It sounds better than guessing. It sounds better than making stuff up. But regardless, they're going to be assumptions, are going to be bets against the future, right? And if I'm wrong in my assumption, it's going to come back to haunt me or whatever poor developer is left with sort of fixing the problem if I'm gone. And if there is sort of an unresolved conflict hidden there, that's not going away either. Now, when talking about this, I also want to talk about sort of the backlog using the backlog as a decoupling mechanism between businesses and IT. And unless it's very clear, this is a terrible anti-pattern, but I think it's quite common. Right? How it works is like this. So your backlog is basically a priority queue, right? And then you have the business people here. They're producers. They put tasks in the front, and then you have developers that sort of consume tasks in the back. Now, this is psychologically very comfortable because we don't have to sort of talk across tribes, right? But it's also sort of a guarantee for accumulating inadvertent debt because there is no feedback here. There is no conversation going on, and so we must make assumptions instead. So the byproduct of this feature factory is the accumulation of socio-technical debt. And you'll notice I've sort of stuck this socio in front now. Right? Because it's not just code, it's debt in the sense of conversations that didn't happen or didn't happen at the point in time where it should have happened. It's relying on mental models that are increasingly weak and outdated and ad hoc. And of course, code eventually that isn't what it should be. And this is the part where you sort of have your technical debt. I always like to quote my friend Remo, who said that if you remake awful software from scratch without changing the culture that created it, you'll just remake awful software. Because it's not just about sort of our best practices and how competent the software developer is, it's this entire process, right? So, we've come a long way from ugly code. So why do we still talk about technical debt? Now, first of all, obviously, the consequences are made manifest and visible at the technical level. You cannot ignore the consequences of these processes at the technical level because it turns into a mess over time. Of course, also, as developers, you tend to look for technical solutions to all kinds of problems, including the sort of so-called soft problems, which turns out to be the hard ones. And these technical tasks are really tempting, and they fit our training and expertise. Doing these technical tasks is why we became, many of us at least, became developers in the first place. And they involve little in terms of psychology and politics. They rarely lead to conflict. Technical work, in essence, is puzzle solving, right? Which is great. Modeling work can reveal tensions, and we may need to involve these business people. Now, on that topic, sort of who owns technical debt? Whose problem is it? Right? And the rest of the organization would love for technical debt to be the problem of the IT department, right? Because then it's nicely contained and compartmentalized and doesn't involve them at all. All they need to do is be a little bit generous, a little bit benign, offer the poor developers some respite, give them that refactoring sprint so you can clean up in the mess that they made. Right? That makes you feel really good about yourself. And the IT department will also love for the technical debt to be the problem of the IT department, because then we sort of hold the key to our own salvation, right? All we need is a little bit of time to clean up, right? After being hit by all these impossible demands, right? We just need to clean up a little bit. Give us some time. But it's not going to work. We saw that. We'll lose the game. And we'll lose much quicker than we needed to. So I'd like to return to these questions now. What makes a meme successful? Right? Is it the idea with the greatest explanation power? The best idea? Or is it the idea that is most effective at reducing cognitive dissonance? I hope I have convinced you that we need to work together to reduce this amount of technical debt that we produce over time, because it's not a purely sort of implementation-related problem. It's a product of this larger process, which involves the entire organization. And there are no technical solutions to technical debt. And the reason is that technical debt isn't technical. Thank you. I think there is time for some questions if there are any. Any questions? If not, you can catch me afterwards if you want to have a chat. Okay. Oh, there's a question.
Thank you for the talk again. What's your suggestion? What's your idea how to tackle technical debt, even if it's not technical?
So how do you tackle technical debt? Well, it's a good question, because that's the real problem, isn't it? I think it helps to consider it as a byproduct of these larger processes. So we need to be aware of that and then try to put in place more healthy processes where we sort of where everyone that's involved in the process of making software is aware of sort of the consequences of how we do this, right? Well, I don't know much more to say than that, really. More questions?
Hey, have you ever given this talk to the business people?
I have, in the sense that in the organizations that I've been working in, the two last organizations I've been working in, I have given this talk. It has, surprisingly perhaps, been received quite well also by the so-called business people. I don't know if they're prepared to change much, but they like it when I say it.
Because it strikes me as, I mean, you're certainly preaching to the converted with me. I mean, I already agree with everything you've said, but it's the sort of game of persuasion,
yes,
right, which is very hard to do.
Right, yes. Yeah. I agree, and there is something, there is basically an entire different talk about how do we organize ourselves. I was talking about sort of using the backlog as a decoupling mechanism. It fits well into a general pattern of sort of trying to isolate the developers and leave them in peace. And I think maybe if we want to fix this problem, and it sort of relates to what you were asking earlier also, that maybe we need to reconsider this model of sheltering the developers, because that necessarily means introducing some sort of messenger that runs between, right? This is your team lead or whatever, tries to sort of bring whatever the developers are talking over to an entirely different realm, which is the business realm, and sort of say the necessary things over there and then run back and say, well, this is what they said, and so on and so forth. I think we need to move away from that model if we really want to tackle this, I think. Of course, we then have the problem that, well, we're exposing the developers, and sort of the rest of the organization needs to somehow not drench the development team in that new environment, right? In the sort of the toxic environment of the larger organization as a whole. Of course, we need to untoxify that rest of the organization, I guess. Right? Does that make sense? Or?
Yeah, it does. Yeah, thank you.
Yes, another question. Feel free to, the rest of you, sort of feel free to leave when you need to get a coffee or have a rest break or whatever, but yes, your question.
Sure. Yeah, thanks for the talk. Really enjoyed it. In terms of, you spoke about being able to measure technical debt.
Yes.
I guess if it accumulates over a period of time, you're going to, your delivery cycle is going to slow down. So maybe
yes.
The chat mentioned about being able to sell it, you could potentially sell, we're going to deliver quicker if we tackle this technical debt.
Yes.
Could that be a selling point, do you think?
I think I think people are trying to do that, to say that, well, we're slowing down, and that's why we need this refactoring sprint. That's sort of because the issue is always, well, what we get in return. We get nothing for the refactoring sprint, right? So as developers, you're left saying sort of blindly that, well, it's going to speed up what we do afterwards, and you have really no proof of that. Right? They just have to trust you. Trust us, it's going to speed it up, right? And that's a fundamental trust issue, I guess, right? But I mean, if we're working in software, basically everyone who works in software for a period of time knows that it slows down over time, right? And it has something to do with these degrees of freedom and how things fit together and the assumption that we've accumulated. But yes, I think that's a selling argument, but at the same time, it requires trust, because we cannot point counterfactually to say, oh, look how much slower we were when we didn't do the sprint, right? Yeah.
Yeah, agreed, yeah.
More questions? I think maybe we have time for one more.
Yeah, again, thanks. You mentioned domains. Do you think like domain-driven design and development kind of stuff offers something in regards to like remodeling?
Yeah, I'm kind of a domain-driven design kind of person myself. I didn't sort of want to include that also in this talk, but yes, I think the idea of sort of bounded context, trying to strategically apply context to your domain, and also just the idea of staying very close to the domain, right? That's as your best hope of not being bogged down in artificial assumptions that you didn't need to take. Just sort of take the assumptions you need to support the way you understand the business, not sort of other things that you think might be the case. So yes, I think domain-driven design practices might help. Yes. Okay, I think maybe for further questions, just come talk to me afterwards. Thanks.